Why is it important to consider multiplicity when determining the roots of a polynomial equation? It is important to determine the roots of a polynomial equation, especially if they're multiplicity, because that tells you how many times it'll bounce when it hits that number. For example, we have the equation y equals x squared plus 6x plus 9. So when you factor it out, you're going to get x plus 3 and x plus 3. So then you have a multiplicity 2 of -3. Like you have two -3s, which means this equation is going to bounce off of -3 when it comes to -3 on the x-axis instead of passing through -3. Over here, we have a cubic function, a cubic polynomial. And the equation is, oops, forgot the y. Y is equal to x cubed plus 3x squared plus 2x. And then if you factor out one of the x's, it can also be written as y is equal to x parentheses x squared plus 3x plus 2. But when you factor it out, you get y is equal to x parentheses x plus 1 times parentheses x plus 2. So in doing so, this means your x values are equal to 0, -1, and -2. You have to set this equal to 0 and then solve for x in order to receive these numbers as your roots. So if we look at the graph, we can see when x, as the function approaches -2, when you put -2 in here, it passes through -2. Then it passes through -1 as well, and it passes through 0. Compared to if we had two of the same numbers that were our roots, it would bounce off the axis instead of passing through the values.